We're now going to start to talk about some items in the work in Chapter 5. Chapter 5. And it has to do with identities. Now, identities occur in lots of different areas of mathematics. In particular, they occur quite a bit in trigonometry because the 6 functions we're dealing with have so many different kinds of relationships. They're interrelated in a very tight web. There are many properties that exist, and there are different ways of relating these functions to each other. Some of these are called identities. Now, in mathematics, the word identity means, roughly, it's a statement that is true for all values for which the variable is defined. So, some of these identities we're already familiar with. We're already familiar with what are called the reciprocal. The reciprocal identities. We know that sine of x is equal to 1 over cosecant of x. That's true from our XYR definitions. And earlier in the semester, we actually went through a proof that this statement is correct. Now, we're not saying this statement is true all the time. What we're saying is it is true for those values for which this statement is defined. If it were ever to occur that cosecant were equal to 0, then this would not be true. Another circumstance is tangent of theta is equal to 1 over cotangent of theta. Well, this is true only for those values for which the statement is defined. If there is a value for which cotangent is equal to 0, then this statement is not defined and this statement is not true. So when we say identities are true all the time, it's with a caveat, and we understand there's a caveat. The caveat is that they are true for all values for which the statement is defined. And so, I'm going to list some of the basic identities we've already encountered in the class, and then we'll start to talk about some other identities that are useful too. So, there are, in no particular order and in no particular sequence here, there are the reciprocal identities. So we know that, I'm going to use x instead of theta. We know that cosecant of x is equal to 1 over sine of x. Now, if we know this, anytime two fractions are equal, you may invert both fractions, the result is still equal. So if you do the reciprocal of the left-hand side, 1 over cosecant, that's equal to the reciprocal of the right-hand side, 1 over sine. So in this expression, we actually have two identities, that cosecant is equal to 1 over sine, and also sine is equal to 1 over cosecant. I list it this way because this is typically the way this is used. Typically, you'll have an expression involving cosecant, and you will replace it with one involving 1 over sine. That's not always the case, but that is typically the way this is done, and that's why typically this is the one that's listed. Similarly, we have secant is 1 over cosine, and we have cotangent is 1 over tangent. So those are the 3 of the basic identities. These are what are called the reciprocal identities. We also have that, again, I'm going to talk about x's instead of thetas here. Tangent is equal to sine over cosine, and cotangent is equal to cosine over sine. So these are sort of the basic identities, the basic values that we're going to start with. And again, those are the basic identities, the reciprocal identities, and these identities are using sine and cosine. What this allows us to do is to take any expression. If we take any expression involving those functions, cosecant, secant, cotangent, tangent, cotangent, These identities allow us to take expressions involving 1, 2, 3, 4, 5, these 5 statements, and express them solely in terms of sine and cosine. Now notice we can write this. We could have written cotangent as cosine over sine. So all of these functions, all of these expressions can be expressed solely in terms of sine and cosine. You could rewrite this, right? We could rewrite cotangent as cosine over sine. So one thing this allows us to do is to take any such expression and rewrite it or re-express it in terms of only the sine function and the cosine function. Turns out that's a very convenient and very important tool that we're going to use in our arsenal to be able to do this work. All right? So, the next batch sort of identities are the Pythagorean. The Pythagorean identities, and as the name suggests, they have to do with what's going on with Pythagoras. One thing we know is this. We know that from our earlier work, we have that sine squared plus cosine squared is equal to 1. I want to brush through this just a bit to review ourselves on, if nothing else, on the notation, but also on the statement. To actually demonstrate the truth of this statement, we can say, well, we know that sine theta in the x, y, r definitions is y over r. And what we mean by, let's go off to the side here. What do we mean by sine squared of x? Remember, this is simply a shorthand for this expression. Sine squared of x means the quantity sine of x raised to the second power. This kind of thing happens so frequently that we have developed this shorthand notation so you don't have to continue writing these parentheses all the time. Similarly, if we had, for example, suppose we had cosine to the third. What that means is cosine of x, the whole thing raised to the third power. This is simply the shorthand form. So when I say sine squared of x, what I mean is sine of x, quantity squared. When I say cosine of x, cosine squared of x, what I mean is cosine of x, quantity squared. And then the rest of this is simply algebra. This is y squared over r squared plus x squared over r squared. The denominators are already common. This is y squared plus x squared. And this is x squared plus y squared. Remember, that's the very definition of what r squared is. And so this is r squared over itself, which is equal to 1. And so we actually have this statement that we've talked about earlier. We actually ran through a similar proof to this. In fact, this is essentially the same thing earlier in the semester. But we have this is called the fundamental Pythagorean identity. Now, what I've done here, sort of along the way, is what we're going to be doing quite a bit with all of these identities. We're going to be establishing the truth of a particular statement. In this case, so this is actually, we have proven that the left-hand side, sine squared plus cosine squared, is equal to the right-hand side, which is 1. So we'll talk more about that in just a bit. I got a little bit on the sidetrack there. But this is the fundamental Pythagorean identity. From it, we can generate others. One thing we may do is simply rewrite this. If, for example, suppose you subtract cosine squared to the other side of the equation, then what we would have is sine squared is equal to 1 minus cosine squared of x. And so this is technically a different identity, but really it's the same identity, just written in a different form. What this means is, for example, if you have a statement involving sine squared plus cosine squared, you may remove it and in its place put 1, simplifying the expression. Or, if you have an expression involving 1 minus cosine squared, you may remove it and in its place put sine squared, and you've simplified it. Similarly, what we may do, go back to the original. This time, instead of subtracting cosine to the right-hand side, subtract sine to the right-hand side, sine squared. And so we would get cosine squared is equal to 1 minus sine squared. it might on the surface appear that we have three different statements here, but really they're all the same property, the same relationship, just expressed in a slightly different perspective. Anytime you have an expression involving 1 minus sine squared, you may, if you wish, if it's convenient, remove that, in its place put cosine squared. And it turns out vice versa. There might be some circumstance where you have cosine squared, and for some reason you would encounter the problem, you remove it, in its place you put 1 minus sine squared. What we're saying is the left and right hand sides of these are now interchangeable. Now, there's another way to manipulate this. Take this original expression and divide each term that appears. Divide each term. So I have sine squared plus cosine squared x is equal to 1. Divide each term by sine squared of x. Everybody gets divided by sine squared of x. Essentially, this is the multiplicative property of equality. So everybody gets divided by sine squared. Divide through by sine squared. Why, you'll see here in just a moment. Now simplify each piece. Sine squared over sine squared is 1. Cosine squared over sine squared. What is that? Cosine squared over sine squared. Well, cosine over sine is cotangent. Cosine squared over sine squared is cotangent squared. And what's 1 over sine squared? Well, we know 1 over sine is cosecant. So 1 over sine squared, if you square this side, you square this side as well. And so we generate another identity. I'm going to erase this piece and move this up to a little bit higher station. So this is another of the fundamental Pythagorean identities. And just like we manipulated this by subtracting things to the other side, you may, if you wish, if it calls for it, you may subtract some of this to the other side of the equation. You may move the 1 across. Cotangent squared is equal to cosecant squared minus 1. You may subtract this to the right-hand side. Now, in this particular case, to generate this, we took this piece, and everybody got divided by sine squared. Now let's go back up to the top, but this time, and let's see if we can do this in our mind's eye, divide everything that appears by this time by cosine squared. Well, what's sine squared over cosine squared? Sine squared over cosine squared is tangent squared. Cosine squared over cosine squared, everybody's getting divided by cosine squared. Cosine squared over itself is 1. And then 1 over cosine squared, 1 over cosine is secant. So 1 over cosine squared, if you square the right-hand side, you square the left-hand side. And again, there's another identity, and we may, if we wish, move the 1 to the other side. We may move the cotangent, the tangent to the other side. So just as this can be rearranged, this can be rearranged. Now, to this day, I'm telling you, to this day, I do not have these two memorized. Whenever I need them, I just mentally do what we did here. Go back to this one. This one, there's nothing for it. This one needs to get memorized. This is the fundamental Pythagorean identity. If you don't learn this, you might as well just give up on trigonometry. This is the foundation. Everything's built on this. But take this and do what we just did. Divide if you want the identity that involves tangent, divide sine over cosine. Divide everything by cosine squared and you'll generate this. If you want the one involving cotangent, you divide everything by sine squared. So if you know this, you can generate all the rest. So these are the basic identities, the reciprocal identities, the change to sine and cosine identities, and then there's the Pythagorean identities. So those are the basic identities. These, all of these, without doubt, all of these, and certainly this, and either memorize all these or be able to generate them as you need them. But all of these, everything up here, needs to be at your mental disposal. You either know it by memorizing it, or in this case, know it by memorizing this and then recreating the piece that you need when you need it. But all of these need to be in your basic baseline knowledge of basic identities. These are the tools we're going to use to do other things. And if you don't have these, the other things don't have a chance of happening.